In 2026, writing 1,000 lines of functional code takes a large language model, like 3 seconds.
Yeah, basically no time at all. Just
Okay.
blink and it's there.
Right. But fixing the chaotic system-wide disaster that code causes when it, quietly breaks your server, that can take you weeks.
Well, easily. Weeks of just pulling your hair out.
We are living in a moment where generating software is essentially free, which means the bottleneck in technology is no longer creation. The bottleneck is trust.
Which completely inverts the traditional role of the software engineer,
Totally.
The primary skill is rapidly shifting away from just knowing how to type out syntax. It's moving entirely toward knowing how to interrogate, constrain, and evaluate the output of a machine.
A machine that is way faster, but, much more reckless than you are.
Exactly. It's like having an incredibly fast intern who occasionally just hallucinates.
Right. So, welcome to today's deep dive. We are getting right into the mechanics of that massive shift today.
It's such an important topic.
It really is. And we're doing it by looking at a build report from a tech blog called Tech-Reader.Blog. This was published on July 25, 2026.
By a software engineer named Aaron Rose.
Right. Now, on the surface, the post is just this simple walkthrough of using ChatGPT to write a bash script for a Raspberry Pi.
But it's so much more than that.
Yeah, looking closely at his methodology reveals this masterclass in the modern engineering workflow. Our mission for this deep dive is to show you a highly specific blueprint for how humans and AI are actually collaborating right now to build reliable systems.
Because the stakes underlying even a simple script are what make this analysis so vital for you to understand.
Yeah.
The internet is just flooded with AI-generated code snippets, right?
Right.
And people blindly copy, paste, and execute them all day long.
Without a second thought.
Exactly. It is incredibly rare to find a practitioner who meticulously documents the gauntlet they run the AI's code through before they ever allow it to touch their actual hardware.
Okay, let's unpack this, starting with the guardrails. Because Aaron fundamentally rejects the current trend of what people are calling vibe coding.
Vibe coding.
Right. Vibe coding is this pervasive habit where someone types a vague conversational wish into a prompt, lets the AI spit out 3 pages of complex logic, and just runs it to see what happens.
It's coding by feeling. You're just relying on the AI to act as both the architect and the safety inspector, which is, well, it's a terrible idea.
It's so dangerous. Aaron takes the exact opposite approach. He dictates rigid architectural constraints before the AI is even allowed into the process.
What's fascinating here is how those constraints separate a professional workflow from a hobbyist experiment.
Right.
His objective was to build a maintenance utility for the Raspberry Pi operating system. He needed a script that would refresh the package database, meaning it checks for available updates, and then actually upgrade the installed software.
Standard maintenance stuff. But his design goals were non-negotiable.
Very strict.
He demanded a clear terminal interface. He demanded a time-stamped log file. He required that the script stop immediately if any single command failed.
Yes.
And the most defining constraint of the entire project, the generated code, had to be small enough to fit on one single computer screen.
That one is brilliant.
I love that one-screen limit. It's like asking AI to build a customized Swiss Army knife, but demanding you can see all the tools at once.
Oh, that's a good way to put it.
Because simple software is easier to trust and maintain, right?
Right.
You want to be able to see every single gear turning at the exact same time. If one tiny tooth on one gear is broken, it is instantly visible.
Exactly. If you allow an AI to generate a sprawling multi-file script for a simple task, bugs and, hallucinated commands have a million places to hide.
Yeah, they just get buried.
Restricting the output to a single screen forces maintainability. You're capping the cognitive load required to understand the tool. It forces the AI to prioritize elegance over complexity.
And the requirement that the script stop immediately upon a failure, that's equally crucial.
Oh, vital for system administration. In bash scripting, this is typically handled by setting a specific flag, usually set-E.
Right, set E.
If an update process fails halfway through because, say, your Wi-Fi momentarily drops, you absolutely cannot have the script blindly plowing ahead to the installation phase.
Because it'll just install partial packages.
It will corrupt dependencies
Right.
and potentially brick the entire operating system.
Yeah.
So Aaron isn't asking the model to figure out what a safe script looks like. He is engineering the boundaries of safety himself.
Yeah, he sets the rules. So with those boundaries set, He writes prompt number 1. He feeds those specific constraints into the AI, and it instantly generates version 1 of the script.
Which is the generative phase we are all very familiar with right now.
Right, getting the code is the easy part. But here's where it gets really interesting.
Yeah, this is the pivot.
He doesn't copy the code, he doesn't test it. He takes version 1, pastes it back into the prompt window, and issues prompt number 2, asking the AI to ruthlessly review his own work.
This pivot from generation to evaluation is the core of a mature AI workflow. He is forcing the underlying neural network to switch contexts.
But I have to challenge the logic of this two-step process.
Okay, sure.
If we are dealing with a highly advanced model, right, and it clearly knows how to identify flaws and make the script better during the review phase, why didn't it just write it perfectly the first time in prompt 1?
That is the big question.
Why rely on a secondary prompt to uncover its own blind spots?
Well, it comes down to how large language models allocate their computational resources, their attention mechanisms, based on your phrasing.
Okay.
When you ask an AI to generate code from scratch, it operates in a highly probabilistic generative mode. It seeks the path of least resistance.
Like it's just predicting the next most likely token.
Exactly. Based on massive volumes of standard, often mediocre training data, it is optimizing for completion. Just get it done. But when you provide existing code and explicitly ask it to review for edge cases, security, and best practices, you are activating a completely different conceptual framework within the model.
You're forcing its attention mechanism to shift.
Yes. It weighs tokens related to safety and vulnerability much heavier. It shifts computationally from how do I build this quickly to how could this potentially break?
That makes perfect sense. By prompting it to act as a critic, he creates this automated feedback loop. And actually, the AI's self-review was surprisingly insightful.
It really was.
It analyzed its own version 1 and noted that the overall structure was clean. It specifically highlighted that set E flag we mentioned earlier.
Recognizing that implementing that stop-on-failure safety feature made the script appropriate for manual execution by a human. The model understood the real-world implications of the syntax it chose.
But the truly valuable part of the self-review was when the AI identified what it missed.
Yes, finding its own blind spots.
Exactly. The AI noted that while it included a logging function, the logs were pretty bare bones. Like they needed more system-level context to actually be useful for debugging.
Which is totally true.
And even more impressively, the AI suggested that the script should probably pause and ask the human for explicit confirmation before blasting ahead with the software upgrade.
That's a moment of profound self-correction. The model realizes that while the prompt asked for an automated utility, upgrading an operating system is inherently a destructive action.
It alters the state of the machine.
Right. The AI concluded that a human should probably type Y or N before those destructive changes are actually committed to the disk.
And these observations didn't mean version 1 was broken, right? It just meant the AI had successfully drafted a roadmap for a much safer version 2.
The AI played the role of the rapid prototyper and then stepped right into the role of the junior code inspector.
But the final checkpoint in this workflow, and this is key, belongs exclusively to the human. Aaron takes the AI's generated code, digests the AI's self-critique, and then implements his own rigorous human review before he types a single command into his terminal.
He puts the code through a 5-question gauntlet.
Yeah, think about the last time you copied and pasted something from the internet. Did you ask yourself these 5 questions?
Most people definitely don't.
Right. So, question 1. Do I understand the purpose of every single command on this screen?
Crucial.
Question 2, is anything happening automatically in the background that shouldn't be? Question 3, would I be comfortable scheduling this script with cron, meaning letting the computer run this utility in the background at 2:00 a.m. completely unattended?
That's a huge test of trust.
It really is. Question 4, does the outputted log file contain enough granular information for me to troubleshoot if I wake up and find the server broken?
Also essential.
And question 5, could another human being, perhaps another Raspberry Pi owner, read this file and immediately grasp what it is doing?
Those 5 questions represent the absolute gold standard for adopting AI-generated code. Generating syntax is just a commodity now. Taking responsibility for the execution of that syntax. That is the actual profession.
Because executing the script is where the human accepts the liability.
Yes. Hardware does not care that ChatGPT wrote a piece of software.
No, it doesn't.
Your hardware only registers that you, the user with administrative privileges, authorized its execution. Aaron is actively accepting the liability for this code.
And the hardware context here is absolutely fascinating and really explains his level of caution.
Oh, definitely. Let's talk about the hardware.
He is running this utility on a Raspberry Pi 5 with 8 gigabytes of RAM, utilizing the Raspberry Pi OS Bookworm.
Which is a solid little machine.
Yeah, and looking at his broader body of work on Tech-Reader.Blog, it's obvious he's operating at a high level. He recently published a piece titled The Great Minimal OS Showdown, where he compares Diet Pi to Raspberry Pi OS Lite specifically for use on headless servers.
And for anyone who doesn't know, a headless server is just a computer running without a monitor, keyboard, or mouse attached. You only interact with it remotely over a network.
Exactly the environment where you need supreme confidence in your automation. If a headless server breaks, you can't just glance at the screen to see an error message.
No, you're totally blind.
It's like you are flying an airplane through dense fog, and your log files are your only instruments.
That's a great analogy.
He also wrote this highly technical deep dive called Running AI Models on Raspberry Pi 5, getting really deep into the architecture of its quad-core Cortex-A76 processor and its LPDDR4X RAM.
Right, LPDDR4X being low-power, high-bandwidth memory. It is incredibly efficient, but on an edge computing device like a Raspberry Pi, resources are always fiercely constrained compared to, say, a massive cloud server.
You don't have endless memory.
No, you have to manage memory, CPU cycles, and thermal output meticulously. An engineer who spends his time optimizing LPDDR4X memory allocation is not the kind of person who lets a chatbot arbitrarily modify his file system.
No way.
He respects the physical limitations of the hardware.
Which brings us back to his demand for a time-stamped log file. He explicitly noted in his build report that the automated logging was his absolute favorite feature of the script.
Because in a headless environment, that log file is literally the only evidence you have that the machine is functioning properly.
Adding a comprehensive log file is what transforms a disposable script into a maintainable engineering tool.
Exactly. A basic bash script performs an action and exits quietly. If a package fails to install, the script just terminates and you are left with a broken system and zero context.
Just a mess.
But a timestamped log provides a forensic paper trail. You can see exactly which package caused the failure at what exact millisecond. It turns AI-generated text into an audible, professional-grade utility.
So after putting the script through this entire process, the constraints, the generation, the AI self-review, the human liability check, he finally executes it.
The moment of truth.
And version 1 runs perfectly, the packages update, the logs are written, status successful. But because he approached this with the mindset of an engineer rather than just a tourist, he immediately envisions how to scale this basic utility into a really polished application. He outlines a highly ambitious blueprint for version 2.
Right, incorporating all of the feedback from the AI's review and his own hardware experience. The transition from version 1 to this proposed version 2 is the leap from a personal convenience script to something resembling actual enterprise software.
Yeah, each of these V2 ideas is tiny on its own, but together it's like turning a basic paper checklist into a fully automated mission control dashboard.
Let's hear the feature list.
It's extensive. For version 2, he plans to implement colored terminal output for better human readability.
Always helpful.
He wants the script to run an active internet connectivity test before it even attempts to contact the update servers.
Very smart.
He plans to add an available disk space check to ensure the Pi has enough room to actually download the new packages. He wants it to detect if a system reboot is required after the upgrade. He is adding the optional user confirmation the AI suggested earlier.
Right, the Y or N prompt.
He plans to format the log outputs in JSON. He wants automated email notifications upon completion, automatic log rotations so the text files don't eventually consume the entire SD card.
A classic Pi problem.
Yeah, and most intriguingly, a fully functional dry run mode.
Oh, that's huge.
I mean, does having a dry run mode fundamentally change how much you can trust an AI tool?
Oh, absolutely. Implementing a dry run mode fundamentally alters the trust dynamic between the human and the automation.
How so?
In a dry run, the script executes all of its logic, evaluates the system state, and outputs exactly what it would do, but it stops short of actually committing any destructive commands to the disk.
So it's a simulation. You get to see the future before you authorize it.
Exactly. It allows the human to verify the AI's decision-making process completely safely. And coupling that with JSON logging is just a massive leap in maturity.
Right, JSON or JavaScript object notation. It moves away from plain text sentences that a human has to sit there and read and organizes the log data into predictable key-value pairs.
Exactly.
Hmm.
So instead of a messy sentence saying update failed at 2 p.m., it outputs structured data that other software, like a network monitoring dashboard, can instantly ingest and analyze without any human intervention.
He is treating this AI-generated snippet with the same respect and rigor as enterprise-grade software.
Aaron is applying proactive engineering judgment. A reactive engineer writes a basic script, waits for it to crash because, say, the Wi-Fi dropped or the SD card filled up, and then scrambles to patch the bug.
Right.
Proactive engineering anticipates the chaotic failure states of the physical world, checking internet connectivity and verifying disk space before initiating an upgrade that ensures the script handles those edge cases gracefully, exiting with a clear error message rather than a corrupted operating system.
We really have to frame this workflow within the context of the tools available at the time, too.
Oh, for sure.
This build report was published on July 25, 2026. Just 3 weeks prior to that, on July 1st, Aaron was covering major shifts in the AI news section of his blog. He noted the return of the Fable 5 model and Anthropic's launch of Claude Sonnet 5.
The underlying neural networks generating this code are evolving at just an astonishing velocity. Models like Claude Sonnet 5 possess reasoning capabilities that eclipse the tools we had even a year prior.
It's moving so fast.
But Aaron's methodology proves a timeless point. The raw power of the generation engine does not negate the necessity of a rigorous workflow.
No, not at all.
The LLM can write the code faster, and it can review the code deeper, but the framework of evaluating risk, anticipating hardware constraints, and architecting safety that remains an entirely human discipline.
So synthesizing everything from this build report, a clear picture of modern collaboration emerges. The artificial intelligence is a fantastic drafter, right? Capable of producing functional bash logic in seconds.
Yes.
And when appropriately prompted to shift its attention mechanisms, it also serves as a surprisingly good junior code reviewer, readily identifying its own missing safeguards.
But the human remains the ultimate decision maker.
Yeah.
The human must design the constraints. The human must demand the audit trails like JSON logs and dry run modes.
You have to know what to ask for.
Exactly. The human must weigh the output against the physical realities of the hardware, whether that is a Raspberry Pi 5 or a massive cloud cluster. The engineering judgment, the decision to ultimately press enter and alter the state of the machine that cannot be automated.
You are no longer laying the bricks yourself. You are walking through the digital structure, tapping the load-bearing walls, running the simulations, and deciding if the architecture is sound enough to actually trust.
Which forces us to confront a pretty profound shift in the nature of our work, leaving you with a thought to mull over.
Yeah, what does all this mean for the future?
If artificial intelligence is rapidly becoming exponentially better at both generating complex code from scratch and analytically reviewing its own work to find flaws, what is the core function of the human moving forward?
That's the million-dollar question.
Will the future human programmer's job look less and less like being a writer of code, and almost entirely like being a judge presiding over a courtroom of AI arguments?